AI agents or agentic AI, it's a hot topic in today's AI world. When you think about LLMs, you go today, you ask a question, you get an answer, you summarize a document, you generate documents, and that's all easy. But when it comes to agentic AI, the capability is different. The use cases are different. AI agents are capable of observing a situation, deciding what they want to do, and going out and doing that action. However, when you take that AI agents concept and deploy it in the context of computer networking, what are the limitations? What you need to think about? What is really possible to do at this stage and what you should not do at this stage? All these questions, in addition to other use cases, I will discuss today with my guest, Rabih Maroun. He's a technology executive with deep roots in telecommunication engineering. He wrote a very interesting couple of articles on LinkedIn discussing this topic, so please stay with us. Rabia, thank you very much for being with me today. You've actually written two very interesting articles on LinkedIn. I personally love them because they talk about a very hot topic nowadays, the agentic AI, not only from the technology perspective, but you took it from a very interesting angle, which is the networking, right? So you did really challenge the entire narrative when it comes to agentic AI and networking. I'm very interested to know what was the moment, the thing that you've seen or experienced that made you write these articles?
Thank you, Samer, for hosting me. Great privilege, and it's an honor to talk on your podcast. Actually, the turning point for me was realizing that most discussions about agentic AI, the current ones in the market, with this frenzy era of AI, all these discussions and the marketing hype, they frame the problem incorrectly. We have a tendency in this era of AI to treat everything as if it is a software intelligence problem, as if all our challenges in control and science is simply to make models smart enough to reason, plan, and select the right actions. To a certain extent, this is correct, but it's not always correct, because in many of the physical situation of physical setups, ecosystems of real life, the difficulty or the criteria are not only intelligence. They cannot only be modeled by software. Let me give you an example. The challenge appears, or let me give you the example of networking, which I chose for my article. The challenge appears when AI system moves from operating inside a software, as I described,
Right.
where the environment is relatively well defined. You know, in software, it's like a virtual world. You have all the aspects of the software, although they might be vast, very big, very numerous, but they're still designed and well defined. So AI in these systems, like a very well-defined process, even if it's very complex, for example, if AI want to play chess, it can play chess, but chess, although it's very complex, but there's a limit to the moves that you can do. Although limit could be in hundreds of millions of even billions, but still it's definite and defined. So this is one aspect where AI can work, but when it moves to a different context, to environments relatively less defined, physical, dynamical systems, such as network. And I will argue a little bit later that the network is not only one system, it's multiple worlds intertwined between each other. Then the problematic is not a software. It's not a large language model problematic anymore. It becomes a problematic of distributed physical infrastructure governed by feedback dynamics. And this is what every mechanical engineer, every electronics engineer, knows very well. So although it's very huge thing to have a large language model, but this large language model is not large enough to englobe the whole reality, the physical reality of life. I'll give you an example. For example, in network, there's the traffic flows, they evolve, they queue, they dissipate, routing protocols, they converge between different physical systems, multiple control mechanisms, different protocols working with each other. Also with physical constraint, the fiber optic, the laser, the governance, the human mistakes, or the SLAs, it's huge. It's not something that you can assume that you can model inside the software. Although one can argue that the software can be very elaborate, but till now, you cannot summarize the physicality, the totality of the physicality of a network. Or I could argue also not only network. There's lots of similar value chains or systems or agglomeration of multiple systems in physical reality that cannot be safely controlled autonomously by an agentic AI. So I'll elaborate a little bit on this aspect. You know, in software world, in software-based reasoning, the environment that you create or that you assume to control, because, you know, the ultimate assumption is to have autonomous control. Like the agentic would replace the human. If you observe the cases where this is successful, you see that the environment is continuous. There's no delays. There's no uncertainty. It's fully visible, and you have the telemetry, and it's Markovian. No, and we discuss about this Markovian.
Yes.
Later, but in reality, this is not the case. And for example, let me take again the network example. The entire state of the environment is not known because it's very complex and it's not stochastic. It's not linear. There's latency, there's packet loss. Packet loss is not because of deterministic aspect. It could be because of software problem, physical problem, saturation. You know, these are not stochastic, not linear things that can be modeled. So this is the problematic of, let's call it partial observability, not because we're not good enough to observe, because the element that we are observing are not yet occurring. You know, they occur in a random manner.
Yeah, I want to comment on this one. Rabih actually made a very good point, because when you think about agentic AIs, first step for them to work is to observe. So they need to observe, they need to understand, and then they need to decide, and then after that they take an action. And what you're saying here, networking is not that, easy. It's not linear when it comes to different, I would say, layers, traffic flows, different components from physical to logical, that you can really get a total observation around it and give that capability for the agent AI so it can eventually take the right decision and take the right action.
Exactly. The agentic and now we're talking like mathematical principles or concepts. The agentic AI tries to form for itself a vision of the world or a state of the world at this particular moment.
Exactly.
And when it's Markovian, it means he assumes that from what he sees, this is all. But physical reality is not, it's non-stochastic. It's in which perspective? It means you could see a state A and a state B. They look similar, but the history of state A is different than the history of state B. And then the progression of these two states is different. You know, like this is like if you remember during the university time, we studied magnetism, you know, like the magnet. So you see the curve is not like a function. The curve would have, for the same x, 2 points on a scale of y. You know, so it's not a function. It's and an agentic which sees a state of the world. Okay, he assumes that he knows it. He will make an action. So what will happen? There's things which will come, and comes from the world of control theory of the feedback loops.
Mm-hmm.
So he could be wrong on the control gain. For example, he does an action, and instead of improving, the gain is too much, and he pushes the system into a different reaction. Right. And then he's in a control loop, and he starts pushing more and more and more, and then it diverges. It means
it amplifies.
And also, what makes the vision of the world or the state of the network very difficult to predict or to model in a software manner. There's multiple interacting control mechanisms, you know, in a network. It's called coupled control loops. So you would have, for example, congestion control, load balancing, the security isolation mechanism of the different loops, you know, like and every loop is coming from a system, and every system has its own logic. And this logic is not complete. This logic is reacting with the environment. It's physicality with automatism. It's not automatism or automation, automatism in French, automation based on software. No, it's automation based on physicality, you know, which the protocols try to abstract. And then you have a system which is non-Markovian. You know, you cannot predict in it. So from a marketing hype, when you go on LinkedIn or everyone's trying to sell agentic AI as if it's something beyond physics, beyond the mathematics. And this is where I wanted in my articles to highlight there's still mathematics and there's still physical constraint and there's still the classical, math and classical logic still applies here. To argue also, large language model, machine learning, they are all based on mathematics and feedback loops, and so they are not beyond them. There's now kind of image we're trying to show the AI as if it's something from the order of a new human or something mystical, or it's not. It is still under the rules of physics, physicality, and this was the reason why I wanted to highlight this fact.
No, this makes sense. Think considering the environment that the agentic AI or the AI agents will work in is very important, and also understanding the limitations when it comes to, as you said, the physical world, the mathematics, how things work is very important, because eventually you're creating a software-based that's a bit more intelligent agent that can go out today and try to do things for you, but you need to be very much aware of these limitations. This takes me actually to the next question, which you mentioned a little bit now, the Markov decision process. You mentioned that actually in your article. So basically, this is the mathematical foundation that most AI agents are. So what's the core assumption it makes, and why does that assumption start to crack in a real production network, in your opinion, Rabih?
What is the key assumption in a Markovian universe, or the Markovian property? The main mathematical assumption is that the present state of any system summarizes the past. It means when you reach some state as a system, and if you know this state, it doesn't matter what happened in the past, because this present state summarizes all the past. And for example, in chess, chess given and this is came from game theory, this Markovian and actually the agentic AI, this problematic of automation and autonomous automation, it has to do a lot with game theory. If someone is interested, if you study the maths behind game theory, you would understand a lot about the basic concepts or the fundamental concepts of agentic, the strategic thinking of an agent, how we can decide. So, for example, chess. If you remember when you open a newspaper, I don't know now, not so common, but before, or if you open a chess book, for example, you will see a diagram where you have like this position. While analyzing this position, you don't care about what happened in the past. The position itself, you see the king, the queen, the pawns, This position itself, it summarizes everything. This is everything you need to know. You don't need to know what happened in the previous moves. You just need the position, the current state, and from there you can do your analysis and predict the next move. And this is the ideal example of Markovian. This chess diagram, the square, where you have the pieces, is enough for you to understand what to do. Let's go back to a physical agglomeration, physical setup of multiple systems, like the network, for example. This is not the case. In a network, there's a present state of the network, but this present state evolves depending on the past actions. For example, if you see a network governed, for example, by a BGP protocol, the way this network will continue being stable, or the decision of routing, or depends on earlier routing decisions. So at a given state, or imagine this network A, on Friday it behaves in a way, on Saturday it behaves in another way. So the past is always following you, The convergence timers, the policy propagation delays, the previous congestion episode, which this protocol machine into different states. So the past is always carried, so it's not Markovian.
Mm-hmm.
It's not that when you reach a state, the past doesn't matter. No, it is stochastic.
So because it's not Markovian, how does that affect the agents, the network?
So the agent, every time he's trying to decide, he cannot decide. When he tries to read the state of the network, always his understanding or his vision of the state of network. However, even you can write a million lines of code, you cannot understand the state of so he will always be taking partial decision because he has partial observability and because he doesn't know what happened in the past. So he could take a snapshot, but this snapshot is not enough for him, of the current state, it's not enough for him to decide properly. Why with a human we can do it? Because human, we are on a slower decision loop. We stop, we ask, we go check, like he's on a faster decision loop. He's like trying to, and this is his advantage, that it's agentic and it's fast, and so the fact that he's on a fast loop, he doesn't have the same mechanisms that we have as a human organization, human mind, the way we consult, the way we govern, documentation. So in our behavior, like an engineer who's trying to make an action, he has better insight of the stochastic state, of how it is evolving than the software that is taking a snapshot and thinking that he knows what's happening and taking an action. Because he cannot do this in a non-Markovian. So two networks can look identical in the present and still evolve differently because their histories are different. And when you are trying to agentically rule autonomously a network or a system, anything in industry or anything, assuming that it's Markovian, it's not Markovian, you end up in a wrong mathematical assumption. And the model is not. And then when the model is not right, he starts making a wrong action. And you see, we end up again in the same control theory pitfalls, which is gain, like the gain, it means when your control gain, when your control is wrong, it starts gaining more into being in the divergence. So, and feedback delays, and stability margins, and you end up like you are doing the classical mechanical control problematics. You end up like having to deal with this, and the agentic software is not capable of doing this because it doesn't have the logic nor the mathematical foundation.
So Rabih, I want to ask you, so on this point, do you think having a human in the loop, or in this case, let's call him engineer in the loop, when it comes to this whole state of agentic, not understanding the past, it's not Markovian, do you think this could solve the problem to some extent so it can lead to some meaningful outputs eventually?
Actually, it's all about having a human in the loop till the moment you have what we call general AI, like AI which resemble the human beings in the way they act with each other, the governance, the way we elaborate, the way we, till you have this robot which looks like you, talked like you, can become your friend. And it is always about having a human in the loop. And from where the strategies that are adopted by companies to reduce the human element, for some gimmick, which is they're happy, like a small child happy with the toy, like, yeah, I have now agentic AI, let me reduce my engineering force and put some software gimmicks and they're going to do the job. This is, from a mathematical perspective, with all modesty, is going to fail. Actually, this what constitutes the AI crisis, is the immaturity, lack of maturity, which unfortunately big companies, profit and loss strategies are built upon, that the AI would reduce the importance of the role of human. It's not the case. If you ask any academic doctor or any someone who doesn't have a stake into this world, someone from outside the corporate world, they would raise for you these problematics that we're talking about. There's limits to software. It's still software.
Correct. I agree with that. Actually, it's very important to understand what AI in general and agentic AI can do at this time. We know this changes on a weekly basis. Many people predict AGI, what you're talking about, general AI that can, to some extent, or almost exactly mimics the human brain thinking and has the total intelligence of the word and try to apply it. And that would be a different discussion, I would say. When we reach that point, it will be a different discussion on what it can do in the technology in general and in networking in specific. And also it opens the topic about AI safety and related subtopics. And this is where I want to ask you about something you described in your articles. You said there are 3 levels of what AI can safely do. You said there is the cognitive amplification, bounded micro-agency, and guardian autonomy. So walk us, Rabih, through these. What does AI genuinely add value today, or where does AI genuinely add value today, and where does it become dangerous in your opinion?
Yes, and these levels are my theory as well, and the theory of many people researching in this field. These are ROI safe levels as well, or self achieving return on investment levels. Any strategy which doesn't foresee or take this into consideration, like how you can reach achievable ROI, which tries to jump over this, is bound to failure. So the first level, which any company is trying to implement AI should have it as first target, to reach, is the cognitive amplification. So you need to have AI helping your humans, your resources, your engineers, your employees, your administrators, to think better, to analyze logs, correlate, telemetry, generate configuration. And this is within the value chain, within the process structure and the very complex relational configuration or relational network that you have. So first what you do, you cannot come and break this process, the human process or the human organization, because of someone told you that AI is some gimmick, some with this hype. You have first to do, implementing AI is to come and amplify the cognitive of the employees. Once you've done this, you start implementing what we call bounded micro agency. So you start automating, or you start introducing agency, like AI be acting on behalf of human, but in a micro manner. Let's take the example of network. For example, instead of having a network agentic engineer, you'll have a network agentic engineer, which can do some small traffic shifts, restart some services, like trigger predefined failovers, but not doing something. And the key here is that the action space and the width or the importance of the change are constrained. So you don't end up in feedback loops, this instability, and destabilize the whole system that you are trying to agentically control. So this is bounded micro agency, and this could be the second level of maturity in your journey to implementing AI. And the third level, and I believe that this level, at present, this is the maximum level of that you can reach safely in agentic. It's the guardrail autonomy, and this is the highest safe level. And here, from micro to pre-engineered emergency responses, for example, isolating compromised segment, blocking malicious routes. These are, for example, from a network perspective, it's pre-validated containment actions, and behind them there's kind of engineering the response. There's engineering, and agentic AI is not. It doesn't assume that it understands the state of the system and it goes into the loop of changing it, which is equivalent to autonomy.
Yes.
It doesn't assume it's autonomous. It is still in a guardrail. This is why we call it guardrail autonomy. It's designed autonomy. It's not free autonomy. If you leave the agentic, and I'm not talking only network, in any system which is physically complex and it has different. If you leave it doing this, it will take you into a systemic risk of imbalance. It's catastrophic, really. And maybe in a different podcast I can show you use cases or which went very wrong, in the world of agentic. And this is
what you're saying, Rabih, here is to do it safely, think about it from the, first of all, help your engineers, help your team to amplify this cognitive ability they have, right? As you said, that's number one, right? So today they write low-level designs, they write network implementation plans, they do configuration reviews. How can you give, between two quotations, this additional superpower to them so they can do these things faster, better, and maybe in a higher quality? That's number one. Number two, I like the point about the micro agency. So you don't have today to boil the ocean, right? You don't have to have an agentic AI that go and does everything you want in the network, right? You can choose very narrow, specific tasks that, or maybe, production lines, something just you care about it so much. You can create the right agentic AI for it, and it can take care of that microservice, micro agency thing, right? And by doing that, you get the benefit of the agentic without putting too much, I would say, of a risk and giving too much autonomy for the agentic AI. The third point, the autonomy point and the guardian autonomy. And you just brought to my mind this example where we know today in networking, you can see a malicious attack, you can block it, and you can probably contain it. But the question today, do you want it to go and take the action of changing configuration by itself, of updating the devices on itself? Take that decision that I'm going to do it right now. I think this is where it goes beyond, and this, to your point, that might lead to unhappy, I would say, results in case you don't really control it and you don't really have the right, maybe human in the loop or the right agent AI design to make sure it will not move forward in these actions, and to the point that probably it will be too hard for you to roll.
Exactly. And, many of the attacks, cyber attacks, are using, for example, if you implement in Agentic AI autonomous without guardrails, hackers can attack it. They attack it, they know that it's going to behave in a way that it makes it more vulnerable, so yeah, it's not only that it's gonna destabilize your network; it's gonna become a security loophole. Yeah, it's and that's it. As simple as this. I think the message is we cannot drop everything we know about science, about math, about automation, about AI. Is although I acknowledge it's a revolution, technological revolution, but it doesn't change everything. It comes and complete the picture. Given also this advise levels, like how to go from 1 to 2 to 3.
Yeah, and actually, this is what I wanted maybe to conclude with you with. So, if someone listening today to the discussion, you would say, Rabia, Samer, listen, AI already flies planes. We know about the autopilots many years, right? It already driving cars, right? We see, these self-driving cars. It's even helping in surgery, right? As an assistant to the doctors. So why I should take also care when I go and implement that AI or specific agentic AI in my networks? What I need to keep in mind and how I take this in a very well-defined step-by-step manner so I can eventually achieve the right productivity gains or ROIs and so on. What do you think?
Yeah, the comparison sounds intuitive, and this is a trap. Like if it can fly planes or drive cars, why can't it run networks? But the question, does it really fly planes? Always you have the pilot. And it is there's a misconception that automated pilot is driving. It is in level 3, for example. The automated pilot, or the agentic pilot, is in a guardrail autonomy mode. He knows how to do specific action, but when, for example, there's a wrong telemetry, or there's a storm, or there's something which is outside the limited space, where he can, like going back to the Markovian, where he can read the state and based on it act. And when there is other things, like some fire, or you cannot leave it to the automated pilot. It will cause a catastrophe. The car is a little bit, as a physical system, it's a little bit less dangerous because you can more or less model it, but still so it's the upper level 3. It's guardrail autonomy towards more autonomy. But what's the difference with network? The network, we have to remember, it's not a single physical system. It's routers, switches, fiber optic, and there's no well-defined boundaries to the network. The dynamics of the network are governed by physics, protocols, by software, by traffic flows, failures, congestion, external routing decision, human actions, and also these totality of the system are not controlled by a single authority because it spans multiple operators, administrative domains. It's very complex. It's a large interconnected ecosystem of control systems. So now one could argue I can have multi-agentic. But then in every control system, you need to have a multi-agentic. So it's multi of multi. And then, so yeah, it becomes, if you want to have a agentic, you need to have a software system or software using the LLMs as big as the physical system, which is impossible currently.
Actually, when you look at it from the angle you described, Rabia, how you define a network, where it starts, where it ends, from physical layer up, all the OSI layers that we know about, even up to the applications. That makes sense because you need to define at the end of the day where you want to deploy these agents, what they want them to do, what they can see, what they can interact with. Do they have even the tools and the access to go through the different layers of the network and do changes or actions if they want, or they don't have it right now? So it's definitely a very broad topic, and it's definitely something worth thinking about. I wanted to thank you for this discussion. Great insights. Again, I love the articles. Please continue writing them, sharing them with us on LinkedIn. And maybe in 30 seconds, if you have any final thoughts you want to share with us.
In 2030, let's assume, in the future, the engineers will become the designer of safe autonomy and the operator of safe autonomy. And the engineer will be operating the tools, which are either AI or traditional, because everything would survive in the same, even now you still have analog phones. So this will be the case in 10, 15 years. You still have normal software, you still have traditional legacy automation, AI. It will be a mixture of, in nature, nothing can eradicate anything else. Everything survives. So the future engineer or the future organization is an organization who can preserve its human resources, yet augment them and push them into this safely and logically and humanely in this new domain of AI.
Yes, I agree. So I think the future is not only one. It's not only AI, it's not only humans, it's both. I think the smart enterprises will build their strategy around that, and they will take it in a very well defined step by step to really design and deploy AI agents that can provide the right value at the right time based on the current capabilities that we have right now and based on what can be done on the network from a networking perspective. Again, Rabih, thank you very much. Thank you for the discussion, and hopefully we'll host you again on this podcast. Have a great day.
My pleasure.
So as you've heard from Rabih, Agentic AI is powerful. It will absolutely change how enterprises work today or in the future. But the real advantage will not really come from giving AI unlimited freedom. It will come from knowing where autonomy creates value and where human judgment must still lead. There is a balance that leaders need to get right, and they need to think about it right now. So thank you for listening. We're looking forward for your comments, questions, feedback, and please stay with us for the next one.